Bismillahirrahmanirrahim. I am Professor Jamil and you are watching YouTube channel. Today we are going to solve a problem on Laplace transform, and here is the statement of the problem. You need to find Laplace transform of the function t to the power n, and hence mean whatever you get from this you need to find the Laplace transforms of these two functions. After doing this, you need to identify those values of n for which this formula is not applicable. The general result for this is not applicable, mean prohibited values of n needs to be identified. So number 1, number 2 and number 3, this question contains 3 pieces. Let's do these pieces separately. So in the solution, first make an announcement what you need to do in the first part of the question, and here is your announcement that you need to find the Laplace transform of t to the power n. So therefore Laplace transform after this announcement is equal to, write formula for the operator L, which is from t0 to infinity integration over t into kernel of the Laplace transform, which is e to the power minus st, into the function whose transform is to be evaluated, and this time function is t to the power n, so t to the power n. Now if you see, this integral resembles with the definition of gamma function in terms of Euler integral, which is as, look, gamma of z is t0 to infinity dt e to the power minus t into t to the power z minus 1. You can name this equation as equation number 1 and this equation as equation number 2. Look the similarity. You need e to the power minus, here is a single variable, but you have st, you have two symbols here. So first you need to transform this st into the single symbol. Let's do this. Therefore we substitute st equal to u in equation 1. So this substitution means you need dt as well, and dt will be equal to du by s. Your variable is t and the new variable is u. S is not the variable of integration, so it will be treated as a constant. It is for this reason that s goes down, then differential of t is equal to differential of u and the constant stays as such. Now you also need limits of integration in terms of u, and t equal to 0 implies, use here, s into 0 equal u, and this means u is equal to 0. Now t is infinity, and this implies here s into infinity equal u, and this means u is equal to infinity provided s is greater than 0. If s is not greater than 0, mean s less than 0, mean negative, then negative mean negative infinity, so you will have u equal to minus infinity. But in your gamma function you need plus infinity, right? So be careful that s, the unknown variable here or unknown symbol, has no meanings, that it should be greater than 0. Now use these values in equation 1. So equation 1 becomes, let's see what it becomes. Laplace transform of t to the power n is equal to, here, u0 to infinity, this 0 to infinity means u0 to infinity, then integral dt is your bu by s, and e to the power minus u, e to the power is minus u, because you have substituted st as u, and then t. T is what? T is u by s. So u by s and whole power is n. Now make a little simplification. Laplace transform of t to the power n is equal to u this du by s e to the power minus u into u to the power n and s to the power n, and this makes u 0 to infinity du e to the power minus u to the power n and 1 over s to the power n plus 1. In the denominator you have 1 over, right, s n plus 1. Since integration variable is u, this s is a constant. It can be taken in front of the integral sign, mean out of the integral sign. So Laplace transform of t to the power n is equal to 1 over s n plus 1 and this whole integral du e to the power minus u and u to the power n. Now look, this is something like this, but the integration variable is t. Here you have integration variable u, but in any definite integral the integration variable is dummy. So here you can replace your integration variable t, u to t, because integration variable is dummy variable, right? So you can replace your u with t so that we can compare it with the definition of gamma function. Therefore, Laplace transform of t to the power n is equal to 1 over s n plus 1 and t 0 to infinity dt e to the power minus t and t to the power n. But in the definition, the exponent of t, mean power of t, is in the form of some symbol minus n. Here is only symbol, nothing minus n. So let's adjust this like this. And for this type of thing, this implies Laplace transform of Tn is equal to 1 over Sn plus 1 into t0 to infinity dt e to the power minus t, and this t is n plus 1 minus 1. You may say that I have added and subtracted 1 with n. And why I have done this? Look, now this definition is similar to the definition of gamma function in equation number 2. This piece is same, this is same, t is the same. So z minus 1 mean n plus 1 minus 1. So z is your n plus 1. So here z is n plus 1. So everything here, this, compare with equation 3. What you get, I will write here. Move in this direction. Laplace transform of Tn is equal to 1 over Sn plus 1 into. This whole integral is similar to the integral in equation 2 with z equal to n plus 1, right? So here you will have also n plus 1. So it is gamma of n plus 1, right? So your Laplace transform finally has been evaluated as gamma n plus 1 over s n plus 1. And you also know, sorry, gamma n plus 1 can be turned into factorial. This I have explained in vector 1 on the gamma function. You can check this result from my vector 1 on the gamma function. And this is equal to n factorial over Sn plus 1. Mean gamma n plus 1 is equal to n factorial also. So this is the general formula for Laplace transform of t to the power n. So here is your answer. Let's do the second part. Now you need to find Laplace transform of t square root. Square root mean n is 1 by 2. So let's evaluate the second part. For Laplace transform of t square root, we put n equal to 1 by 2 in above boxed result, right? So this is Laplace transform t to the power 1 by 2 and gamma of 1 by 2 plus 1 over s 1 by 2 plus 1, right? Now this is Laplace transform of t square root, and this is, you can use the recurrence relation for the gamma function, and the recurrence relation for the gamma function is that gives you 1 by 2 into gamma of 1 by 2, denominator is 3 by 2, because gamma z plus 1 is z gamma z, and z is 1 by 2. Look, this is 1 by 2 plus 1. 1 by 2 into gamma of 1 by 2, right? This is 1 by 2 gamma of 1 by 2. Now you know the value of gamma 1 by 2. It is square root of pi. And use it here. So come to this side. This implies Laplace transform of square root of t is equal to 1 by 2 into square root of pi divided by s 3 by 2, because gamma of 1 by 2 is equal to square root of pi. You can check this result from my video on gamma 1 by 2. This I have made a separate video. But it is advisable that you should remember this thing. Okay. And therefore Laplace transform of square root of t is equal to 1 over 2, 2 can be written down. This is square root of pi divided by 2 into s 3 by 2, where s is greater than 0, which we estimated in our previous part of the question. So this is the Laplace transform for square root of t. Now there is another part, 1 over square root of t. That means in the general result, you can name this result as equation number 4, because we have already named equations up to 3. This is your equation number 4. And for transform of this, the n should be minus 1 over 2. So let's use it. For now, for Laplace transform of t 1 over square root, Laplace transform of 1 over square root of t equal to this. Now for this, we substitute n equal to minus 1 over 2 in the general result given in equation 4. Therefore, Laplace transform of t to the power minus 1 over 2, and this is equal to gamma minus 1 over 2 plus 1 divided by s minus 1 over 2 plus 1, and this is Laplace transform of 1 over square root of t, and here you have gamma of 1 by 2 divided by s 1 over 2, and then you move this side, and the Laplace transform of 1 over square root of t is equal to square root of pi divided by square root of s, because gamma of 1 over 2 is square root of pi, or you can write this result in a bit neat form, that it is pi over s and then square root. So this is the Laplace transform for 1 over square root of t, right? So we have done the second part of our problem. Now it's the turn for third part. Which values of n are possible? And let's do this from here. Make a heading: prohibited values of n. Make a heading for this. As you look from equation number 4, you have gamma n plus 1. So prohibited values of n will be those for which the gamma function is not defined. And gamma function is not defined. Look, from equation 4, we see that prohibited values of n means those values of n for which gamma function, and which is the gamma function? Gamma n plus 1 is not defined, and this means that, and from that need to write one more line. Gamma function is not defined when argument of the gamma function is 0, minus 1, minus 2 and so on and so forth. And for this piece you can check my vector number 1 on a gamma function, right? So this means that n plus 1, which is the argument of the gamma function, mean this is z, and this should not be equal to 0, minus 1, minus 2. Okay, you can make an equality sign: 0, minus 1, minus 2 and dot dot. If these are the values of argument of the gamma function, then the gamma function is not defined, and this means n is equal to minus 1, this makes minus 2, this makes minus 3, this 1 will move on the right hand side, and dot dot. So these are the values of n for which the argument of the gamma function will be 0, minus 1, minus 2, and for these values the gamma function is not defined, which means for these values of n, this Laplace transform will not work. So these are the prohibited values of n, because you can emphasize again, because gamma n plus 1, it will become what? If n is minus 1 plus 1, gamma 0, minus 2 plus 1, gamma minus 1, minus 3 plus 1, gamma minus 2, and so on, are not defined, right? You cannot find value of the gamma at 0, you cannot find the value of the gamma at minus 1, and you cannot find the value of the gamma at minus 2. So when you cannot do this, it means you cannot use these values of n. So this Laplace transform is not applicable for these values of n. So these are the prohibited values of n. Mean Laplace transform of minus 1 mean 1 over t, you cannot find it. Laplace transform of 1 over t square, you cannot find it, and so on and so forth. So this completes the solution to your problem. and I hope I would suggest you to do this problem and similar problems with your own hands, because there is no substitute to practicing the questions and solving the questions with your own hands. And I would suggest you, when you watch this video, after watching this video, do the solution by yourself, and wherever you are stuck, you can go back in the video and check how you can get out of your stopping of a solution, right? This will enable you to uh, perform and solve any given problem on the Laplace transform. Thanks for watching. Please like, share and subscribe this channel so that such exam questions and many others like this comes to you in the first place. Thanks once again.